Is it officially top of the hour? Wait a minute or so. Just go.
Yeah, sure. People are still walking in, actually. Easily surprised.
It is the top of the hour. We're going to wait just another minute or two to let people keep walking in. We apologize for the temperature in the room. There is hot tea and coffee right outside for another minute. All right, I don't see people walking in anymore.
Yeah.
Kick off? Sure.
Okay, we're going to start. Here is the agenda. We already have volunteers for JabberScribe. Thank you, Michael. And note taker. Thanks, Melinda. Blue sheets are going around. Anyone have any additions or changes they want to make to the agenda? Going once, going twice. Sold. The note well. This is the first or second time, depending on what you went to yesterday, that you've seen it. It will not be the last. This will not be the last time you see it. So read it now, so you don't have to read it Wednesday, Thursday, Friday. Continued. I can't get the page or the screen size thing to work, so. All right. And then Wes had a few notes to kick off.
So quick couple of notes on how today is going to run and sort of the purpose of this BOF. It's going to start with a number of presentations by Phil, giving sort of an overview of the mathematical mesh technology that he's bringing to the IETF. It comes from a much larger framework than he'll be presenting today, but he has lots of information on that outside this meeting. And he's starting with a proposed starting candidate of password management, which he'll go into a bit later. The goal for us today is to see if there are pieces of this solution that are of interest to you, regardless of whether the larger framework is, your exact need. Are there pieces that might work in other working groups or pieces that might work in other frameworks within the IETF? So the purpose of today is to do just that. What is attractable to the IETF work? And assuming that there is interest in at least some of them, what are the right set of starting components? As I said, his fuller set of technologies is quite large, and we need to find a line of where is the best subcomponents to start within the IETF to get started, and then to find participants who are able and willing to help do the work as well. So finally, as per the agenda, the flow of today is going to be fairly rigorous on the clock management side of things. We're going to keep to fairly strict times in terms of both the presentations that Phil's going to give and then the clarifying questions sections. Do note that the 5-minute clarifying questions are just that. We're going to leave discussion for good, bad, ugly, pieces that people love, issues that people have with it until later. So just clarifying questions after each of those breaks. And then after that, we'll have the discussion, which will really focus on the components of interest to the IETF, what pieces that we may or may want to adopt. And then finally, of course, we'll talk about determining consensus and conclusions, and is this work relevant to the IETF, and is there interest in forming a working group around it? Anything else on you? All right, so I think with that, we'll turn it over to Phil with the first of the presentations.
Thank you very much for coming here to chilly Singapore. Okay, so what I want to do here is to give a brief introduction to what the mesh is about and what problems we're trying to solve. For those of you who have long flights, we also have a video version of the complete presentation, 7 hours of them. And those you can download from the MathMesh site. So I'm not going to get into the detailed technical pieces on any one component here. What I want to do here is to give an overview of the mesh, and what the large problem that we're trying to solve is, why that's important, and so on. Do you have them?
As soon as the data tracker comes back up, there we go.
Oh, okay. Do I get the clicker?
It doesn't seem to work, but you can have it hold on to it.
Oh. Okay, so the objective of the mesh is to make computers easier to use by making them more secure. So the first thing that we want to do is to set we want to stop trying to do good enough security and make it easy for the user to do things, and also get security as a byproduct. And so the first thing we're going to do is, Alice today, she doesn't just have one computer, she has a whole suitcase full. And so the first thing we're going to do is to glue all of Alice's devices together cryptographically, and that is what we call her personal mesh. I don't want to bike shed the name mesh, if we can leave that. So, and then once we've done that, we're going to use that framework to exchange maintenance messages between those devices that we've all glued together. And that will allow us to use strong end-to-end encryption with all the applications Alice uses, as if Alice had one super device rather than a whole bunch of itty-bitty devices separate. Okay, so in order to do this, we've got three core problems we need to solve. The first is we need to provision private keys to all the devices. So every device is going to have a set of private keys for encryption, authentication, and signature. And then the second core problem is, how do we get the public components of those keys to where we need it to be in order to establish our end-to-end cryptography and our data at rest cryptography? So go to the next slide. Oh, and the third problem is to secure data at rest. So today, security, we have a whole bunch of siloed applications that are independent, that Alice has to configure on each of her machines separately, and the configuration can be a real hassle. I was trying to enable S-MIME on a really well-known email application. It took me 15 minutes to do that configuration, and I know what I'm doing. So how is somebody who doesn't know as much about PKI expected to? So today we've got separate products, separate dashboards, and security keeps falling through the cracks. And so if we can glue all the devices together cryptographically, we can start to get a handle on it. Next slide, please. So this is the picture of the mesh in the large. And as you can see, IETF, I've got a narrow waist for you. So the green piece is the mesh itself. So this is the part that is providing Alice with a personal PKI that she's the root of trust for. The mesh depends on three base technologies: UDF, which is the naming infrastructure; DARE, which is the cryptographic message syntax, which is basically PKCS7 plus blockchain type capabilities; and metacryptography, which is about extending the cryptographic tool set from the one that we use today, which was established by PGP and PEM, to add some of the stuff that was invented in the 1990s. And I'll get on to, so I'm going to be addressing each of those blue boxes later on. Now, this is mix and match in that you can decide to do any one of those blue boxes. You can decide to do any two. You can decide to do all three. If you want to do the green box, you have to do all the blue boxes because there are dependencies. So if we build the mesh, we can then build a whole bunch of applications on top of it. As I've been thinking about, how do we manage IoT devices? How do we enable SSH, S-MIME, PGP? How do we make all these things really easy to use? So there's a huge expand, this is a platform. There are lots of things you can build on it. But that's obviously too much for one working group. So if we go to the next slide. So what I'm proposing that we do for phase one is we pick one or possibly two of those applications, and we use that as the proof case in order to build the mesh. Because I don't want to be trying to build 15 applications and do it through a standards process. I don't think that works. But I also don't want to be designing a platform with no reference application. And so I think we need to pick one. And the reason I suggest passwords is, first of all, it's the smallest one. It's about 50 lines of code that is specific to the password vault. If we go to the next slide, it's also where the pain is for the user. This is how we can make computers easy to use by making them more secure. Because if you take away the pain of passwords from the user, you're doing them the biggest favor we can do them in terms of usability today. The shortest password that is secure is much longer than the longest password that you can possibly expect a user to remember. And no, I'm sorry, you cannot get around this with new hash algorithms either. And I can explain why offline. So go to the next one. So the Mesh Password Catalog, as a test application, it tests out almost the whole of the Mesh infrastructure. There's one piece that it doesn't test out, which is deliberate. It doesn't add too much to the code base. And it's an immediate value, because this is something that even if one person is using it and nobody else in the world ever uses the mesh, that person can get value from having an end-to-end secure password manager. So it doesn't rely on the network effect, which, as we all know, is the chicken and egg problem until you've got to critical mass. And one of the feedbacks I've got from certain banks has been, we can apply this to solve the functional password problem, which is, everybody's familiar with username and password when it's in the web browser. There are a lot of usernames and passwords that are embedded in scripts. And those are necessary in order for one piece of infrastructure to talk to another piece of infrastructure. And these are really poorly maintained in many enterprises. They'd like to get a handle on it. So what I think we could do with, independently of anything else, is a really good open standard for a good password vault. And that enables the users to use really long, secure passwords, because this is going to be an open infrastructure that's going to be on all of their devices and can be built into all of their web browsers so that they can use their strong passwords without being tied to one particular vendor. Now, if you wanted to just do that, well, the mesh would be a bit like using a sledgehammer to crack a nut, because we're also provisioning public key pairs onto every device. But in doing that, we're also providing the path to replace passwords entirely and use emerging technologies like the web authentication infrastructure that the W3C has developed. If we could provision a public key pair onto every one of the user devices, that then becomes practical. So next slide. So from a technical view, Alice is going to create a personal mesh and become her own ultimate root of trust. So she can outsource that to a third party, like she does for malware and anti-spam or whatever. And she's going to create she can outsource it, but she can always reclaim her autonomy. She's always going to be the root of trust for her own digital gestalt. She can create a master, so she's going to create a personal master profile, which has, the usual PKIX type of stuff. This is basically key axioms, and you have a master signature key that never changes, and so we can use the fingerprint of that as Alice's permanent fingerprint, and it has administration keys that can revolve and all that good online, offline stuff. So next slide. From Alice's point of view, she has installed an application on a mobile phone. She's created an account, alice@example.com, and now she can add her devices to a personal mesh by maybe as simply as scanning a QR code on the device with a phone, or it might be she goes to the device, she installs an app on it, says, I want to connect to alice@example.com, and then we do a comparison of two fingerprints. So the user experience here is really simple, not much different from what users do already today, and it establishes that this device is connected to this personal mesh with, a good work factor, 120 bits, 128 bits, whatever. And so Alice checks these two fingerprints look the same, she accepts the connection, and now the device is connected. And once the device is connected, it stays connected until Alice says to disconnect it. I have a lot of IoT devices in my house, and what really upsets me is not that I have to program them and that it takes me 10 minutes to an hour each time, but the fact that I then have to reprogram them regularly because they throw away their configurations for stupid reasons. So once a device is connected to a personal mesh, it will stay connected until Alice says to drop it. So next slide, and I think we're coming to... And once a device is connected, they can share access to all the catalogs that are connected to a device. So each connected device now has a shared world view. So Alice can now use a personal vocabulary that is, for voice-activated devices, for example, that is shared across all her devices. So that if she says a command like, Zen, turn on the lights in the yellow room, that can now mean the same to any device she has connected, no matter which device it is, and no matter which vendor has provided it. If she adds a bookmark to one device, that change will be visible to all the others. And what this means is that every connected device can authenticate the messages that are producing all this of being of Alice and do the right thing. So this allows us to establish a single dashboard for IoT devices. So next slide. So there are three basic mesh components. There's the schema component, which is basically very similar to SAML or PKIX, but in JSON instead of XML or ASN1. Sorry about that XML encoding thing. It wasn't a good idea. Then there's the mesh account, which is unusually for an internet protocol. A mesh account belongs to the user, not to a service provider. It is created independently and can be bound to a different service. So this allows Alice to maintain separate identities for her business, personal, restaurant, golf, and whatever, but manage them all as being the same thing as far as she's concerned. And then there's a service which basically just acts as a synchronization point for the catalogs that are connected and provides an always available point of contact for messaging. So if we go to the final slide, I think it's the final one. So what we have now is 5 minutes of discussion, clarification. There's more information on each of these systems on the website, and I go into the details of the architecture in the videos, which are fairly comprehensive. And as I said, we're going to be discussing, this is on the green box. We're going to be coming back to each of the blue boxes in turn. So
as a reminder, clarifying questions of things you don't understand. That was a high-level overview from Phil, and then he'll go into the technical components more in a bit.
Sure. Well, I'll let you tell me if this is a clarifying question. I think it is. So I understand what you're technically proposing here, and I understand that passwords are bad, and I'm struggling to understand how this how this connects to the password thing.
Okay, so if you have a password, if you only had one machine, then you can write a password vault and it just sits on that one machine, and it can create long passwords, and any program that's on that machine can then access the passwords. So you can now use long and strong passwords. If, however, you've got 20 machines, then if you change the password on one machine, you want those changes to be replicated across all the other ones. And you want to be able to do this in such a way that you do not have a password vault in the sky, which has that is available to the service that is animating it. So you don't want to store the plain text passwords in the cloud. Now, there are various ways that you go around it, but if you want to deal with the specific problem of Alice has 20 devices and she loses one, then you need to be able to turn off access of that device without affecting any of the other devices or going into rekeying. And if you want to do that, then you need to have a bit more mechanism than anything that's out there at the moment.
So just to restate what I think you're saying, this is a replacement for the password sync technologies that say 1Password or Firefox or Chrome or Bitwarden has.
Yeah, and it should be a drop-in replacement in that the people who are in those businesses can go to this technology. They don't need to, this doesn't blow up their business model. It's providing them with a new business model that allows them to provide more for the customer.
Great. I have one more question. What happens if I have one device and I lose it?
Okay, there is a mechanism that we can use for key recovery for that. I'll go with.
Okay. Can we table the technical stuff until later?
Basically, if you're going to do data at rest security, you absolutely must think about key recovery, because the worst thing you can do to the customer is to lose the pictures of the kids when they were 5.
For the record, that was Eric Rascola from Firefox in the back. Can you say your name and your affiliation, please?
Mohit, could you go to the user experience slide? It's a couple of slides before. Thanks for having that slide. I think
you've gone past it.
No, you passed it. It's
Alice's.
so this is technical, but then after
next one.
This user view. So I like this idea, but like, who runs this server where Alice has an account? Who provides me with the app? Is it tied to certain devices, and what motivation do device manufacturers have to follow this?
Okay, so yeah, I've been told that that's we'll come back to that. Yeah.
Yeah, Melinda Shore, just don't have to go into a lot of detail, one sentence answer. So how are you providing password consistency if you're not using a centralized storage?
The user chooses a service that provides a Dropbox. So it's kind of like an IMAP server.
So it is centralized.
So,
in something.
It is centralized in the sense that each user at any one given time has a single synchronization point. However, you can change that synchronization point at any time that you like, because the account belongs to the user and not to the service provider. So if you want to change your service provider, you can, and there's nothing that the service provider can do to stop you, and you will have no interruption in service.
Okay, but you're not using like a consistency protocol that's sort of serverless.
Right.
Okay.
Yeah.
And that was Melinda Shore. Next question.
This is Dino. Clarification question. Most of your language seems to want to make it easier for us to manage our multiple devices. But right now in the real world, most people just have one cell phone. And the real problem is managing all the web-based passwords, which are in the hundreds. That should be the high priority problem to solve, or does it solve it at the same time with the device problem?
You can just run this without, if you only have one device, you don't need the service, and it will run quite happily without any service at all. You can create an account without having an internet service.
Will you solve the 100 website different password problems?
Absolutely.
Okay.
Yeah, as many passwords as you like, no problem.
And will that take longer to deploy than the device, solving the device problem, do you think?
Not
clear.
Yeah, I mean,
I think we'll get into those technical details. Michael, last question.
Michael Richardson. So one question from Jabber was, how does this stop a thief who has your phone from getting your passwords?
Okay, so there's two cases here. One case is if you know that you've lost the phone before the thief, assuming that it's not password protected or biometric protected or whatever. If you realize before the thief opens it up, then you can disable it by telling the service, do not perform the other side of the decryption for that password. And I'll come to the math on that in a moment. If, however, the thief gets there first, well, you're hosed. And that's just simply because if you've designed the system so that you can get it at your password without any other pin or whatever, well, if a thief has got it, the thief is you, so there's nothing that I can do.
And my question is, does this work for the situation where I have a phone, everyone in my family has a phone, and it turns out that my TV is also a phone and needs access to some of our common passwords, but I don't necessarily want to share transitively my Facebook password with my son through the TV?
Absolutely.
Okay.
Yes. That's actually one of the things that you would want to do with accounts. And yeah, I mean, like, the structures are there. I cannot guarantee that the usability is perfect. And that's something that I think we'd need to go through a working group to, hammer out the best way of doing it. Okay, so next.
10 minutes.
Right. Okay, so the first of the technology presentations is on UDF. We started out as uniform data fingerprint because we were going to redo PGP fingerprints, and it's become something else. It's become cryptography on Rails. Are people here familiar with Ruby on Rails as a framework? And it's a really great idea. You have one name to refer to everything everywhere, and it simplifies your code. Well, I want to bring that to crypto. So let's go to the next slide. And then it kind of like mushroomed, because we started off with this idea, okay, we've got base 32 encoding of cryptographic outputs. So we've got content digests. And here we've got a SHA-2 and a SHA-3 digest. And we can do message authentication code. And there's a heap of technology there. You can do them at various lengths. They resist semantic substitution attacks and great stuff like that. And then people started to say, well, what if we wanted to put in other things like nonces into this form, or a symmetric encryption key? And that becomes really useful. So we've got a key here that's the input to a key derivation function that can then be used to create ourselves encryption keys and initialization vectors for a piece of data. And then Michael said, well, what about private keys? Can you generate a private key from one of these? And so we did that, and that's quite interesting because now I have a private key that I can generate from a really short, base 32 encoded piece of data. And that's something that I can copy across. So if I'm doing SSH, I need to copy my private key onto multiple devices. Instead of doing it how it's done today by a significant fraction of the sysadmin population, which is to send it via unencrypted email, I can enter the UDF. And then, of course, if you're doing all this stuff with private keys, aren't you going to want to have Shamir secret sharing so you can do the key recovery? And so there's a whole bunch of mechanism in there. So next slide. And this allows us to do what I call cryptography in Rails, which is in the mesh, the only form of key identifier that is used in the mesh itself is the content digest of the public key. And the reason for that is that if you have one way of referring to the key in every place, and it simplifies all the path math that we've traditionally done through PKIX. So if we go to the next slide. The other thing that we can do, I don't know if they've still got the, there's a demonstration of this on the BOF poster. We can create encrypted QR codes. So what we've got here is a QR code which is a combination of a hint that allows us to discover a website that can be converted to a web service endpoint, and an encryption key. And to resolve this, we first of all resolve the example.com to web service endpoint and take the content digest of the encryption key and use that to locate a document that is encrypted. We retrieve that encrypted document and then decrypt that document with the original encryption key, which we hadn't shared with the site.
Oh,
and so now we've got a way that we can put QR codes on documents and pieces of paper that allows that document to link to an encrypted copy of the document in the cloud. So imagine that you're doing your taxes and you've got all those W-2 forms. You could just scan the W-2 form and back comes an encrypted version. You're doing your invoices. You can scan the invoice, come back with an encrypted version. There's a whole bunch of stuff that the combination of this and QR codes solves. The reason that I put it into the mesh was that I wanted a way of doing contact exchange so that if I meet Alice in a bar or whatever, we can bump phones. So next slide.
Oh, sorry, quick question, Mohit. This seems oddly similar to RSC 6920 naming things with hashes. Maybe I'm wrong, but could you clarify what's the...
There is a reason for that, which Stephen will put. I'm one of the authors of naming things with hashes. And so basically, this is coming back to some of the work that I did previously and reapplying it. So yes, I'm not pretending that any of this is new. I'm not trying to be new. I'm not an academic. I'm trying to solve a problem. And I'm quite happy borrowing stuff that's 10 years old or 20 years old. So yeah, so we're now into the discussion of UDF.
Ben Kaduk, could you go back one slide, please? So just to double check I'm understanding this right, with the sort of encrypted URL thing, the idea is that I can put a QR code somewhere and anyone who looks at that QR code can fetch the plain text to the content, but the content itself is hosted on a site that does not have access to the plain text because it's encrypted to the key that is local on the QR code.
Yeah, that's basically it.
Great.
So basically what you have is the QR code becomes a bearer token that allows you to locate and retrieve.
And that was Ben.
Yeah. And you know, it's what it was, you know, I'm trying to do data at rest security here. And that's stuff that, you know, I did with Stephen, what, 10 years now? Yeah, 2011, I think. And, you know, it just looked like the time to put that in as well, since we're revisiting it. So
Phil, can you clarify the first question a little bit more? How is this different than the previous RFC? Or are they compatible? Or are they incompatible? Did you add stuff?
The architecture is similar. What has changed is the syntax and the fact that we're now using the content digests. So they're not compatible, but I think that there are some improvements that have happened since. And Stephen tells me that nobody's using the knee stuff. So I think that if we're going to, you know,
Unencumbered by installed.
yes, unencumbered, yes.
Ecker?
So I'm sorry, I think I just don't understand how this specific, I understand how one would build one of these things, but I'm not sure I understand how you built it. So that first URL,
Yeah.
the thing, the path component, what would be the path component is the encryption key, right?
Yeah.
But there's presumably lots of crap on example.com,
Right.
lots of resources. So what tells me what resource it is?
Well, the example.com piece, you throw it at web service, at DNS service discovery, you know, Stuart's Cheshire stuff. So you look for SRV and TXT records, and those can identify the web service endpoint. And if neither of those are populated, then you fall back to well-known service discovery. And so here we've got example.com. So this piece here, the HTTPS example.com, well-known MMDF, all that stuff is just some stuff that is defined by the UDF example.com piece.
I'm sorry, I think I'm just still missing it. Like, I have like 5,000 resources that I want to post somewhere, each of which has their own decryption key and their own name, right? And where does the name get stuffed? Like, I mean, so at some point I'm going to connect to some like server.
Oh, the name is we get the name to differentiate that's the hash of the encryption key.
Oh, okay.
So we use that to complete the.
But that's not content at rest then, because that's actually the encryption key, right?
Right.
Okay. So I am now not making a clarifying question, but a technical point, which is an unattractive property of this design is that anybody else who has access to the URL is able to forge new content and you cannot detect it. And the typical way to prevent that is to have the URL, have the top thing, the URI, contain an integrity check rather than just an encryption, as well as an encryption key, thus preventing substitution.
Yeah. As I said, let's take this, if people want this feature, we can bash it around. There is far too much PHP in this already, so we need to get other minds involved. Yeah. So, okay, let's go to the next. So, okay, so let's go to the DARE piece. So, since I was doing this this mesh stuff, I needed a way of wrapping up my schemas, and I didn't want to use ASN1 because, I'm fed up of having arguments over it. And so JSON is the format of the hour, so let's do it in JSON. And so go to the next slide. And so the basic spec is simply PKCS7 for JSON, reusing most of the same crypto approaches, with a few changes that allow the use of DARE envelopes in sequences. And this particular change is we generate, instead of having the key output of a key agreement be the master secret that's used to the encryption key, and then specify the initialization vector separately, we use a key derivation function in order to derive our initialization vector, our encryption key, our MAC key if we're not using authenticated encryption, and anything else we might need to use. And we put a nonce into that. And what that allows us to do is to have one envelope that is encrypted under one key exchange, that has a payload that's encrypted, and then has attached attributes that are encrypted under the same key, but can be decrypted separately from the main payload, and to do all of this without the risk of reusing the same key twice, which would be really bad if you're using a stream cipher. And since people are going to authenticated encryption, that's pretty much the norm now. So that's the basic envelope piece. So go to the next slide. Oh, yes. And then, so the other piece that came up is that you're probably aware in the crypto world, there's an argument that goes on as to whether you should sign and then encrypt, or encrypt and then sign. And there are actually disadvantages to both. And so the proper way to do it is actually to sign, encrypt, and then sign. And so one of the ways that this particular key derivation, because of the way that we'd wanted to use these envelopes in the mesh, it's critical that we sign the ciphertext and that we'd be able to verify the signature from the ciphertext alone. But then what if you need to be able to prove that the person who signed the content had knowledge of the plain text? Well, we can generate a witness value out of the key derivation function, and that provides almost exactly that piece of information. It isn't quite the same, and we can discuss the difference offline. So let's go to the next slide. So if we were just going to do envelopes, it probably isn't that interesting. But the main reason that we do this in the mesh is so that we can create append-only logs, which are sequences of DARE envelopes. And this allows two things: incremental authentication via a Merkle tree. So all that stuff that's in certificate transparency, we've got in there so that we can sign the final head of the Merkle tree, and then we can authenticate any envelope in the sequence. And I believe it's used in some minor currency thingy somewhere. I forget what its name is. And it also gives us incremental encryption. So the idea here is that if I've got a log file from my server, I would like to be able to encrypt each entry into that log, but I don't want to do an RSA key exchange for every entry I add. And even if I'm doing elliptic curve, I don't want to have to do a key exchange for every entry, because then I'm going to have to do a key exchange for every decrypt as well. And it's just too much. And so what this provides us with, so this structure allows us to create an incremental encryption, have the key exchange in the first record, and then use that same key exchange in any subsequent packet. And just have a pointer back to where the key exchange went. And so the only thing that you need to do to make this secure is to make sure that each of the envelopes that you have has a different nonce, and then the key derivation function works properly. And yeah, and this can be used also, and since WPAC has been proposed, I did not know about WPAC when I was working on this, nor did I intend to propose a replacement for zip. However, while I was designing it, I implemented a zip archive format as a sanity check on the design to make sure that it worked. And so this might be something that's relevant to the WPAC people. So next slide. Okay, so why do all this? Well, the idea is so that we can create a DARE catalog. So DARE catalog is the persistence store that we use in the mesh, and it is based on a DARE sequence. So we're going to add or change or delete entries in this catalog by appending chunks to the end of the sequence. And the objects can be encrypted. And if you're going to use this as a password format, you might want to consider encrypting the password entries. In fact, I hope you will. And we can discuss the exact way that we apply that encryption. But the big payoff here is that now, because every data structure that is stored on a mesh service is an encrypted DARE sequence, the only thing that we need in order to synchronize Alice's device to her mesh service is to have a means of synchronizing the DARE sequence. If we've got that, we can it will automatically synchronize the bookmarks, the passwords, the contacts, everything, all in one transaction, or all in one set of protocol, instead of requiring separate things for each one. And this means that the mesh service protocol is really quite simple. There's basically the meat of it is 3 commands for status, to get the status of the containers, upload a change to container, or download. And because we've got that Merkle tree going on, we maintain integrity checks all the time. The service can check the integrity of a proposed upload, but cannot read any of the contents of the container because they're encrypted. So next slide. And so, do we have any discussion on DARE?
Discussion,
clarifying questions.
Hi, this is Dino. So it sounds like you said you wanted at the same time, let's solve encryption data at rest problem while you're doing these other things. That's great. It also sounds like you're solving the internet identity problem once and for all, maybe. And at the same time, you're solving device synchronization. Is this true? Huh? Identity.
People have occasionally accused me of trying to solve too many problems at once. Yes.
Well, I mean,
That is exactly
I'm
the
going to
idea.
applaud you for thinking holistically. That's good.
Yeah, I mean,
But-
like, my fault here is that I am a systems guy and I just obsess about these things. And so, you know, what you may end up with here is a really overbaked thing. But I find that as I look, you know, when I haven't got an idea where to go, I look for more requirements and then I try and simplify. And I think that this structure, you know, you don't want to use blockchain to do BGP or DNS or whatever. It's just the wrong thing because blockchain was designed to do one thing, and trying to repurpose it is, you know, like trying to do everything with a hammer.
So you didn't assert this, but I think you are now, is that you want to use blockchain for internet identity. Is this true?
This allows you to do the same things that blockchain would allow you to do. And so all those proposals that are based on blockchain, they make a lot more sense with this. What I absolutely do not want to do is to use proof of work.
Okay, proof of waste, right?
Yes.
So one other clarification question, if that's okay. It sounds like since you're thinking holistically, that's wonderful. But are you worried that you may solve the password problem at the expense of identity? Solving the identity or device synchronization problem won't work as well as you would like. So as a designer, do you think you can do all these things really good, or one really good and the other one just mediocre because it's all together? It's always the dilemma of a designer, right?
I honestly think that at the point that I've got the documents now, there is there's no fat on the bones. I mean,
Right.
it is really concentrated, and I don't think that one compromises the other. There's a few pieces in the current specs that maybe we should strip out, because originally when I was looking at these sequences, I proposed multiple ways of doing the sequences. You could have chains or whatever. I think at this point we should just strip out everything that's not
And you
a
believe
tree.
you have enough detailed design at this point to make this assertion?
Yeah.
Okay.
I mean, this has all been implemented.
Ben Kaduk, so I'm going to get the terminology wrong unless you take the slide back, I think one or two. So the idea is that sort of we have like a 3-tier structure where I can have like an individual DARE envelope that's like the smallest quantum of encrypted stuff. And then I might sort of consolidate a bunch of those into a sequence, I think is the next term. And so like those could be related things, like, you know, one envelope per password in my password manager sort of thing. And then I can have a bunch of these sequences which might be related, and I build those together into their container, which is maybe, I can think of that as like a database of stuff that gets synchronized, and the container is gonna include like the updates and removals, and like this is the latest version of this thing that appeared previously in the container. Is that
That's
right?
pretty much it. I call them catalogs. I was using the term container at one point. And then when I got a review back that was saying, this is really bad, you're confusing me because I'm doing Docker.
Okay, so right, we got the envelope and then the sequence and the catalog. Okay, great.
Yes.
Sorry, I thought I was going to get it wrong.
There's also a spool, and a spool is simply a queue of messages, or it can be a queue of tasks.
Okay, yeah.
So I mean, if there's any IBM folk around here, I can do kicks on blockchain with encryption. I think that could be valuable to you.
Melinda Shore, I actually have two questions. The first one is, when you say blockchain, that usually implies the data structure plus some sort of consensus or consistency protocol. Are you doing both or just the data structure?
What I'm proposing here is just the data structure. What I'm doing, I mean, like I do have a consensus protocol. I presented that at the Boston Hub meeting, and it does not involve proof of work. Basically, the way that I can get around the need for proof of work is by having multiple chains and to then have cross assertions between them. And then the problem with those things is that you always end up with the problem of who's the ultimate root of trust, you know, who do you, and the way that I solve that is to fold it back on the user so that Alice, by when she reincorporates her mesh services attestation into her chain, that becomes her personal root of trust. And so over time, each time Alice is synchronizing, she is reinforcing her own proof of. So we can discuss that offline. I mean,
yeah, because I mean, right, because a lot of the consistency or consensus protocols are based on sort of the Byzantine generals problem, where you assume you've got hostile actors in the network. But the other question,
just to jump in, this sort of consistency stuff is relatively unrelated to most of what we're talking about today in terms of.
Absolutely. Let's take that. I think this is where we wave the rat around, and you know, we can take that off to a bar discussion.
Okay, so let me get more. The other question I think is probably more directly relevant, and that is that Merkle trees are very efficient to do lookups, and they're kind of expensive to extend. So have you done any performance characterizations, and is this really the best data structure for your?
For what I'm trying to do, I think it's acceptable. I've not really tried to do any performance stuff. If people want to propose something that's better, I'm quite happy. I know that there's a whole literature there. And, you know, I'm bringing this here because I need help. I mean, like, I've been keeping this around in my head for 5 years. And I desperately need your help. I cannot continue to build this on my own.
Okay, we do
I'm
need to
looking
move
for
on.
co-authors for all the documents. You know, I really am looking for your help. I'm not here because I want you to see my shiny stuff. I'm here because I want to convince you to work on my shiny stuff.
All right, so we're going to cut the queue after the two people in line currently.
This is Jeffrey Yaskin. How does the fact that this is append-only help with the password use case as opposed to just a file that you replace when you change it?
Basically, it means that I can use the same synchronization primitive for passwords, for bookmarks, for contacts, and for everything else, and for synchronizing messages to the spool. And yes, if you were only going to do passwords, this wouldn't be the absolute optimal way of doing it, because most people aren't going to have enough passwords to make it worthwhile. You know, even if you've got 1,000 passwords like I do, that's probably not going to be enough to justify this. However, once you realize that, you know, the passwords is how you access the your authentication for your website. The other really critical catalog is the contacts catalog, because that is giving you the public key of all the people that you're talking to. And for that, you really want to have an append-only log. And the other piece, and when we get into the metacryptography, the other use for this particular structure is so that I can do true end-to-end encrypted web, by which I mean encrypt from the content creator to the content consumer, in which all the data that is in the cloud is encrypted, and still be able to do social network, Web 2.0 type stuff. Because I can represent a comment forum as a as a spool of posts. So it's all about reuse. Yeah.
This is Dino. Just need a binary answer to this. Is the mesh service decentralized in your opinion?
Yes. Anybody can set up their own. And if you choose a mesh service provider and you decide you don't like them, you can always change. So they're not sticky.
You said mesh service provider, and that made me feel centralized.
Well, yeah, but you can be your own. Yeah. Okay, so this is the final one of the Blue Talks, which is metacryptography. And this is not new cryptography. Well, maybe this is not, this is all stuff that should be part of the canon, but didn't make it because the canon of cryptography that we're using kind of closed in 1990 when PEM and PGP launched. So I'm taking a leaf out of Tim O'Reilly's book, and I'm rebranding it so that we can go back and look at what we were doing that we should have been doing all along. So we're rebranding threshold cryptography and some other stuff with metacryptography. So next slide. So what do I mean by that? Well, one thing that we can do with metacryptography is key combination. So this is used in the mesh key provisioning protocol. Oh, hang on a sec. So if you're doing PKI, the big bugbear of PKI has always been, how do you actually provision keys or issue certificates? And it's really tricky because if you do it wrong, well, everything falls apart. And so you can generate keys on devices, and that's okay if the device has a sufficiently good random number generator. If it doesn't have a good random number generator, you've got a weak key and you get hosed. You can generate your private key in a centralized location, which means that you can do it under controlled circumstances and make sure that you've got a strong key. But then you can't really trust it. I mean, when I was a CA, people kept coming at me and saying, I want you to generate the keys for me. And I'm saying, oh, no, I'm not doing that for you. And so this was a way that I came up with that would allow me to do it for Diffie-Hellman. So one of the amazing facts about Diffie-Hellman is that if you take two private keys and you add them, you can calculate the corresponding public key simply from the two public components. So if you look at the two red boxes here, the two at the top, so private key X, private key Y, Z equals X plus Y. Okay, so they're all Diffie-Hellman. We can create Diffie-Hellman keys for all of them. But look what's happening on the black side, the public key. Public key X is X.P, public key Y is Y.P. Well, Z then, oh sorry, this is elliptic curve, not Diffie-Hellman, not regular Diffie-Hellman. So here we got the public key that corresponds to X plus Y.P. Well, that is simply going to be the addition of the 2 points X plus Y. What? Yeah, yes, Christian is bringing up a bit of number theory. There's a few tricks and whatever, and there's a draft that explains them all, and there's some stuff that I have to go through and put in the draft for the Montgomery curves. But yeah, I mean, like, this does work, and it's really absolutely amazing that it does. I mean, like, you know, I knew that this should work, and when it did, it still blew me away. But okay, so we can combine keys. And what this means is that when you apply this to a key provisioning protocol, we do away with the need for proof of possession. And key provisioning becomes a kind of like a holistic thing, because if you have if the device doesn't connect in the right private key, well, the public key is not going to come out right. So it's going to end up not knowing the right. Yeah. So it ends up with a different way of doing proof of possession and simplifies the protocol at the same time as getting away from the traditional vulnerability of weak keys. Next slide. We can also do it for key splitting. So this is threshold cryptography. So we take a private key Z and we do a key agreement with it in the normal, El-Gamal encryption. So we do a key agreement and we end up with the value A, okay? Well, we can derive that same value A by generating a random number X, which is going to be our first private key, and then using the private key of the encryption group, in this case Z, use that to derive Y. We can then do the two key agreements separately, combine the results, and come up with the same result as the original one. So what this means is, if we go to the next slide, what this means is that we can do encryption in the cloud. We can have a key manager in the cloud that can control use of decryption, but cannot decrypt. And we can prove that this cloud service has absolutely no knowledge of the private key because we give the service the random number. So all the service has is a random number and a bunch of encrypted files. Oh, and we have a different random number for each person that we join to the group. And what this means that we can do now is that we can do group encryption. We can have a pile of documents that are already encrypted, and we can add a new person to our encryption group, and they've now got access to all those documents, all the ones that were written in the past. Because all we need to do is to provide the halves of the keys to the various people, and now the cloud service can enable them. Conversely, if we decide they're a bad egg and we don't want them to have decryption capabilities, we can shut them off at the server. We can tell the server, do not decrypt for Bob anymore. Or alternatively, again, we can have velocity controls in the server. So the server can say, okay, you've decrypted 30,000 diplomatic cables this hour. I'm not going to let you have 30,001. And so it provides us with what I call confidential document control. This is not a full CRM system, because if you've got the ability to decrypt the document, you've got it, and that's it. This is not going to control the onward distribution. It's not going to force you to delete it if you are taken out of the group. So what Bob has already decrypted before he was thrown out of the group, he's still got. However, it does solve the problem of, instead of everybody in the organization who might need access to the document, we can control access to those who actually need it. So next slide. Okay, and this is so do I have clarification questions on the cryptography?
Yeah, so as a reminder, in Rich's well-designed agenda, this is clarifying for 5 minutes about that, and then we'll go into the discussion of, what do we do with the body of work. So this is the last presentation, but are there any clarifying questions on this last segment?
Yeah, I'll also say that if people have, more detailed questions on this, they can come. I'm here for the whole week, so they can come at me. And Stephen.
Stephen Farrell. So you may not have the answer to this off the top of your head, and that's okay. It's unclear to me how what you're presenting remains as simple as it is and meets the sort of group requirements you're mentioning without turning into something as complicated as MLS. So either they're doing something vastly over-complex unnecessarily, or maybe your presentation is making it look easier than it is. Is that fair?
I think that your analysis is correct. I'm not sure whether it would be politic of myself to answer your question. I did try to persuade the MLS people to look at this stuff when they were starting. The difference between what they're trying to do and what I'm trying to do, though, is a matter of there's a difference in ideology in it. They're trying to do off the record. They're trying to make their messages disappear over time. And what I'm trying to do is, if I've got a new employee that I've onboarded and brought into my group, I want to give that new employee access to all the documents, all the chats, all the emails, all the context information, all the online discussions, all the video conferences that took place before. And so we're actually trying to do two separate things. Now, I have tried to get my head around the MLS problem and apply this stuff to it. I think it is intrinsically a harder problem, but that might just be because I'm stupid. I mean, like, this is one of those things that, you know, I or somebody else might wake up one morning and suddenly see, oh, there's an easy way of doing this. But so far, that's not happened to me.
Mohit, so my previous question about who has the app and why do device manufacturers follow this is still unanswered. Something is clear to me now that anybody can be a service provider, including the user can set up its own server. So that part is clear, but is there some standard mesh app that will work regardless of what device I buy or which organization I use? And who will have this app? So those questions remain unanswered.
Okay, sorry. So in order to use the mesh, there's a mesh management tool, and that will create a device profile that contains all the keys for that device. And so you don't need the device manufacturer does not need to cooperate in order to use this stuff. However, if we want to do the type of, however, the device manufacturer did want to cooperate, there are some opportunities that this stuff makes possible that aren't available otherwise. So, for example, the key provisioning piece, what you can do is, say the device manufacturer has a key that is unique to each device embedded into the device. Okay, and the device comes with that. Well, that's a key that cannot be extracted from the device, which makes it really interesting to me. It's also a key that I cannot possibly trust because the device manufacturer might have been coerced. Any piece in the supply chain might have been coerced or manipulated or whatever. However, what I can do is I get this device, I then layer on a key contribution of my own, and I've now got, so I'm going to be doing my device level, my trusted hardware, public key stuff, and also my secondary layered key stuff. And that allows me to use that untrustworthy key in a trustworthy manner. I'm sorry. So if we have device manufacturers that are willing to go this stuff, we can absolutely make use of that, and it can allow a whole new lease of life for trustworthy hardware.
Jeffrey Yaskin. How is trust divided between the server and the clients? It seems like you're hiding the content of the documents from the server, but you're trusting it to add and remove people from groups. Is that right?
The service is trusted to remove people from groups. A person can only be added to a group by the group administrator, and the group administrator controls the key locally. So adding users to the group is always end-to-end. Now, if you get into, if you want to go beyond the level of security that ordinary internet users, say you want to do this in a government type situation, or you want to do it in a banking type situation where you have huge amounts of money involved, we can apply separation of duties. It isn't described how to do it in, that hasn't been reified into code, but I absolutely know how to do it. And there are disclosures and prior art. And I should have mentioned, I believe that this should all be unencumbered as far as I'm concerned. I don't believe that there's any.
All right, last clarifying question. Okay, and Ben.
All right, Joy from Article 19, just building up on the previous question, just wondering if there's going to be provisioning in case that the manufacturer actually wants to block it.
How do you mean?
Like you mentioned, if the manufacturer wants to participate, then they can be part of the key for the device but what if they actually don't want the user to be able to set this up on the device?
Well, then they don't need, well, I mean,
Like, basically, I'm just thinking like about censorship type of.
Oh, okay. I mean, if the user is allowed to install their own applications, they can always run the mesh as an application. If the device has been locked down and so that you have to have the permission of the manufacturer or whoever to run it, and they don't allow secure applications, well, that's not going to be possible. But we can at least, the manufacturer can at least take themselves out of the trust loop, which is good for the manufacturer, I believe, because most manufacturers, they do not want to sabotage their customers. But their concern is not that, it's that they might be coerced or one of their employees might be corruptly induced to do something that then cost the company something. So yeah, I mean, we can come back to that offline, but if there is a sensible answer, I think that we can get to it.
This is Ben Kadek again. To sort of respond to Jeffrey's point, I think it's probably useful to remember that sort of the starting premise here is that we want to make something that is as easy to use or easier to use than what people are currently doing. And to some extent, that might limit the security properties that we know how to provide within those constraints. And so, the fact that we have this slightly weird who is trusted to do what behavior, where like the service in the cloud can remove people, and it's a little bit wishy-washy about how much of a guarantee you have that it does so properly. We still have some other properties that are useful within these constraints about making it easy to use.
Absolutely. Actually, this is one of the things that has really been guiding the whole design, in that traditionally, because we're security people, we try and provide absolutely the most security that we can. And then after we've done all that stuff, it's kind of like, oh, well, how are we going to make this tolerable? Here, it's the opposite way of looking at things. It's how do we make it as easy as possible to use the computer as possible? And then how can we do that securely? And how can security help us do that? So, yeah. Okay,
all right. So for the next section, we were going to discuss, is this an interesting place for the IETF to spend work on? What is the problem space of interest, like password management might be a reasonable starting point? Is there a solvable problem here? In other words, do people agree that this is a solvable problem? Phil doesn't have to necessarily win that battle. Which components of Phil's might be useful in a starting charter, or at least of these he proposed a set of solutions. That doesn't mean that we have to pick his in the problem space that the IETF ends up wanting to work on, and who is willing to help work on it, of course. And is password management a reasonable starting place? Or for those that have read more of the documents, are there are other components that you feel would be even more appropriate, or more anything else to prioritize? Do you want to add anything, Rich?
No, other than Phil, you can sit down now.
Thank you.
You're welcome.
You might still need to answer questions, but Eric Nordmark. So some of the pieces here that was sort of mentioned in passing seemed quite fascinating. The ability to take a hardware-based key, like off of a TPM or something similar, and then augment it with something else, so that you now can leverage that hardware with a trust, but still not completely trust the manufacturer. The slides refer to some IoT use case, and one of the things I want to explore is whether we should do that here now, because I want to make sure we can do this for devices that don't have user interfaces, where all is on the device might be the barcode of the key fingerprint of that public key that's in the TPM, and make sure that stuff works, because that's very interesting to me, at least. So.
Hi, Roman Donato, No Hat. So since the words working group were used, I guess I'd be interested to hear from the community. Are we talking about a working group whose success is governed on we solve the password problem, or are we looking at a working group that is picking out specific technologies that we talked about here, and we're going to advance and mature those technologies, and we happen to maybe solve password stuff along the way?
That sure sounded like you had a hat on.
From my point of view, I would really prefer that we did the second, and that we use the password application as a sanity test, but that isn't the output of it. If you want to produce a password manager, there are simpler ways of cracking that particular nut. The reason for wanting all this mechanism is because splitting up the problem space allows me to then solve a whole bunch of other problems in the same vein. And on the IoT side, I've been deliberately trying to isolate myself and think about this separately from specific applications that aren't already deployed. I'm absolutely willing to interact with them, but I needed to get my stuff done before I start to talk about how to interact, because otherwise you just go crazy.
So, hi, Roman back. I'll put the hat back on. So my, I think I understand kind of what you're saying. I guess I want to hear a lot more conversation about, I don't know how to measure success. And I understand that password is, a way to test that we got it right. But I guess I'd want to hear kind of more discussion on what success would be advancing any of those technologies, kind of what the constraints would be. Would password be sufficient?
Michael Richardson, the mic. I'm with Phil in that I would like to solve passwords along the way to creating a set of technologies that have multiple applications. I'm not sure how to answer your success question, but certainly if we fail to solve passwords, we would be a failure. Okay, so I think we can identify some failure conditions, which would mean stop working and continue, if that's useful to the IESG. I think that the document in the cloud, decrypt, etc., that interesting thing that isn't quite, but is almost like MLS, has an interesting IoT application, which is the devices. One of the issues with, and anyone who has considered upgrading their phone has gone through this quandary, either replacing your phone or upgrading the operating system, either because it got destroyed by a bus or whatever, is that all of these things would really like to save their configuration encrypted securely, that no one can mess with it, in a way that that device or an equivalent device can retrieve the configuration and resume operations as if nothing had happened. I heard an hour-long conversation at a meeting in September of the OPC, where this is an operational IoT consortium, where they completely rat-holed into that conversation about that, and critically, it was obvious that that was a serious stumbling block for them to adopt any onboarding solution, because it was clear to them that it was pointless to onboard a device that didn't have a valid configuration. Right? If you onboard it automatically, then you send the technician up to set up the actual configuration. Well, you missed the whole point of automatic onboarding if someone had to go configure it, right? And so I think that's an actual really interesting second use case that really has nothing to do with passwords and isn't necessarily the Snowden problem, but is in fact tractable at a small space.
Ben Kaduk. So with no hat, I want to say I'm actually pretty excited in the same vein as Michael about getting to work on some of this broader technological solution, because there's a lot there that excites me. I think there's a lot of potential in some of these new technologies, especially the sort of meta cryptography stuff, to make solutions for a lot of use cases that we just haven't been doing in the IETF before. But I think there's probably a lot there that that would be interesting to look at more. I think I've also looked at the drafts for like the UDF and the DARE stuff a little bit more, and there's a lot of interesting ideas in there. And there's, as Phil was saying, there's still a lot of room for more co-authors to come in and flesh out some of the bits and make sure we're getting the details right. So I think there's still work to be done to get that into the best shape, but I think it's worth pursuing.
And Phil gets bonus points for putting SVGs in this document too.
Eric Piccola, sorry, I just stepped out for something else. So I guess the question I was going to get at earlier, but it was not clarifying, so I didn't ask it, is there are quite a few people who already are doing password sync systems. We have one. I know Google has one. Every one password has one. There's iCloud, et cetera. We, by the way, are not unaware of these ideas. In fact, the initial Firefox system used opaque for this, which has some similar properties to the design Phil's suggesting here. My question is, which, if any of those, wishes to consume this? Which, if any of those companies who build systems like this wishes to consume this technology?
So I don't know who you're directing your question to.
Philip,
Certainly not me, but
is anybody in this room who is there anybody in this room who works at a company like that like is interested in it? I can tell you that I guess speaking for Firefox, like this is a somewhat different set of trade-offs and design trade-offs we decided to make, and I don't think we'd shift to these.
So let me rephrase that question, Ecker.
Sorry?
So let me rephrase that for 1 sec. So to answer other people's question of what would be a reasonable successful outcome of this working group, a reasonable successful outcome would be interoperable password management, right? So there's two sides to your question, right? There's the user, do users want it? And are there companies willing to do it even with or without?
Well, I mean, the reason there's not interoperable password management is not that I don't have like a phone number to the guys at Chrome who do password sync, right? It's just not. And nor is it the fact that I don't know Chris's phone number and can't call him. Is that the companies who do this don't want interoperable password management. But I guess what I'm saying is that if in Phil's presentation, this use case was presented as using the password management example to drive the technical requirements for building these other systems. And what I'm saying is that if that's true, then there ought to be people who build systems that are password management sync systems who would be interested in this. And I'm trying to drive with that fact is true. Is there a customer for this technology? Are they here in this room, right? Or do they exist? Yeah.
So Ben Kadek, to jump in, I think the prerequisite to answering that question is there anybody in this room who is building a password manager product? And if we get silence to that, then silence to the other question isn't really meaningful.
Sure. Well, I mean, Firefox has a password sync, a system that syncs passwords. It has a somewhat different set of design trade-offs than this, and we would not change these design trade-offs, I don't believe. Chris, I don't know if you can speak for the iCloud design. Okay, so I guess, I don't know, but similarly, if those people are not in this room, then we have no idea what the requirements are, and we solve the problem. So I guess my question I'm asking is, are there demonstrated consumers of technology who are, when we did MLS, right? We had a line of people who said we're interested in this technology and we would consider adopting it if it were done. And so my question is, are there people for this technology who want to say the same thing?
Have any of those people been to IETF meetings before, unlike, say, messaging and real-time communication and so on?
I guess I don't understand the question. Can you restate it?
I'm saying you're asking if anyone in the room is building or working on, let's call it a competing product, right? We've never seen 1Password, password safe, Schneider's KeyPass, whatever the hell.
Well, I guess I can tell you that there are at least 3 big systems that have people in this room.
I understand.
Working that build password sync systems, which is to say Firefox, Chrome, and Apple. And they're all in this room. Now, I don't know if the relevant people are in this room, but it's not like no companies aren't represented here.
Okay. Good point.
Thank you. Next.
So thinking about DARE, I don't feel like the append-only log aspect of it has really been motivated enough. And if that goes into a working group, I'd want to see that piece motivated better.
Melinda, sure, that makes sense. So In the IETF, we don't really work on interesting problems because they're interesting. We work on technologies for which there's demand, and I think this is related to Eckert's comment. And so, Phil put a massive amount of work into this. It's great stuff. He's the only author on this stuff, right? And even though we saw the BOF was coming, there were no other contributions. And so I'm wondering just, what the landscape out there actually is for this stuff. The other thing is, I don't think we should focus overly much on the password management aspect of it, unless that turns out to be the product. But I think there's also seems to be agreement that it would not be the product. The technology would be the product.
That's fair, and I encourage people that want to work with Phil on elements of it. A couple of people have said you're interested in other components, not necessarily in the password management space, to please state that you're interested in helping Phil. Microphone in the back first.
Yeah. Hello? Hello? Is that working? Yeah, okay. So Lawrence Lundblade, I think there's probably about a 30 to 50% overlap of some of the work being done in the FIDO Alliance. They're, of course, centered around biometric authentication, and that's their solution for replacing passwords, but there's always a fallback to something. But the whole idea of eliminating passwords or doing something better about passwords, that's in parallel. The idea of binding multiple devices is areas that they're exploring that's relevant to authentication, and then they call account recovery or sort of backup systems for authentication. That's also work that's being explored there. So there's some white papers and some things like that. So I just wanted to, you were asking about people in the room that have some familiarity, so that's just mentioning that some work in the FIDO Alliance that's paralleling this.
Ben Kadek again. So I guess Melinda sort of started to cover some of these topics. Could we go back to one of the original slides with the orange and the green and the blue boxes, please? So like we're talking about passwords because that's what Phil has proposed as a potential use case that would be a concrete realization of this technology, but without trying to boil the ocean. But there's no particular reason we have to be tied to that. There's other potential use cases, if people are interested in those other ones, we can talk about those instead of passwords. And the other point that I want to make is that even if we're talking about passwords, that's sort of relying on the green box, the mesh core, and it might be worth taking a step back to look at the blue boxes to say, do people understand what these three technologies in the blue boxes are trying to do, and think that they might have use cases for those as well. So let's not focus too much on the orange part yet, if we're getting ahead of ourselves by doing so.
Yeah, I definitely heard interest in some of the blue box. Front microphone, then back, then front.
Eric Nordmark, you asked about other use cases. So if it wasn't clear before, at least pieces of this stuff, I would actually apply to what I would call IoT or edge computing in an open source project next week if I had it. So, because I think that there's things you can do here that I haven't seen anybody else be able to do before. So is that the whole IoT bubble on this thing? I don't actually know because I don't know exactly what's in there. But I think that if we only focus on the password side of things, that use case, we might wander off in the weeds.
Alex Mayover from Nick.at. Regarding similar initiatives or similar work, I believe that what's related to that could be the work within the W3C, within the Decentralized Identity Working Group, where they are essentially trying to do pairwise encryption based on cryptography. There's a little bit of blockchain for public discovery of private key, public keys and revocation as well. So that might be very well related. And there's a lot going on in that space. There are like 100 billions of startups coming out of that area. The main goal of that infrastructure is to get rid of passwords as well, and also to do something where you don't necessarily reveal all the attributes that you have to some entity just because you want to authenticate for something. So but it's like mobile clients, self-sovereign identity, and decentralized identifiers is the keywords. Yeah.
Thanks. Phil, can I give you a leading question since a couple of people have mentioned it? You sort of made this statement at one point that you're getting rid of passwords. You're not actually getting rid of passwords, right? You're making it easier to store longer passwords, which you also said at one point too. So it's not a passwordless system. It is a password storage system.
Well, the orange box is a password system. However, in order to access that password vault from a particular device, you have to connect it to the mesh, the user's personal mesh, which means that you've already provisioned a key pair set for that account, which means that we can now layer in whatever keys are required by web authentication, FIDO Alliance, whatever technology tries to replace passwords. So it is not just a password management system. It is a password management system which, by having deployed it, you have met the hard precondition, the stumbling block for getting away from them, which is having a private key on the device.
Got it. Passwords plus. Got it.
Yes. So it is. So now, as far as I would be overjoyed to do IoT. I mean, like, I would really like to do that. I've got no objections to doing different scopes or whatever. The reason that I chose password was purely because that is something I can show concrete value to me as a user. And no, Eric, no, the Firefox, the Mozilla password management is absolutely useless to me because all my passwords are in Chrome. Every one of them. And I'm not going to use Firefox because I am tied to Chrome because that's where my passwords are.
Okay.
And if you want me to use your product.
Phil, let's not get in a flame war over password managers and which ones are best.
So yeah, I mean, like I was just pointing out that
yeah, no, I understand
the
the
user's
problem.
position is not the same.
Thanks.
Ben Kadek, sorry to jump in front of David, but Phil, would you consider it a friendly amendment if I said that this is not necessarily a password synchronization protocol, but a key synchronization protocol, and we just consider passwords as kind of a really lousy type of key?
Yeah.
Because I would want to consume this to synchronize, like, my SSH private keys or my PGP private keys, and it's just as easy to do that as to synchronize the passwords.
Hi, David Skenazy, Google Chrome. So one way that I'm kind of reasoning about this, in particular, because like Philip was saying, a lot of the primitives here aren't new. And this kind of feels like what I might call a grand unified theory of cryptography, like a way to tie many things together. And in general, the IETF does not do grand unified theories well, because you can't really reach consensus on grand unified theories. And in particular, what the IETF generally does really well is solving specific problems. So for this, one approach is pick an orange box and solve that problem and then say, oh, by the way, one of the things, like when we completely only focus on that, and that also requires people signing up for that box. Like if we pick passwords, we need people who make password managers to show that they're interested, for example. But we could pick another box. And then we do some work, and then maybe along the way we say, oh, by the way, we can reuse this for something else. But right now, like, this seems really way too vague for this to be tractable.
Is there a problem space that you would pick that would be a good target?
Personally, I don't see a box here where people who live inside the box are interested in a fix that is a wide solution. So another way of phrasing that is, for a lot of these individual problems, people have come up with a special case solution. And while it is incredibly attractive to have a unified solution for many things, those historically fail because it's really hard to build a Swiss Army knife with 72 different knives in it wherein all you want is scissors.
Eric Pasquarella, David said a number of the things that I would have said, namely, I think it would be best to pick a single orange box and attempt to solve it. And that would, and the place to start with that is there a consuming community which wants that box solved, and which thinks this is an attractive way to solve it. To go back briefly to the password manager example, I don't know the specific password management products as well as I know the browser products. But the browser products typically password sync. The password is part of a generalized sync system where there's a system where basically you can have arbitrary crap sync between the browser endpoints. And passwords are one of the things. So history is an example, typically bookmarks, that kind of crap. I mean, I think one might imagine that the browsers would be interested in having a standardized protocol for doing that. I don't know if that's true. One might imagine that's true. To be honest, I'm not sure we'd be ready for that. I don't know the Chrome guys. As I say, I think that the vast majority of that work, if we were to take on that work, would not entail this cryptographic issue, but would entail actually like harmonizing the data structures and handling some of the things someone alluded to earlier, which is conflicts and multiple dual updates from different points. Like all the complexity, like probably like 85% of the complexity in Firefox sync is there. It's not in the crypto. All the crypto is somewhat complicated. I guess so. To go back to the basic point. Let's find a customer for this that's excited about it, and then charter the work on that to solve the problem of that customer.
Michael Richardson, I echo Eckart's thoughts, and some of the complexity I think that you are referring to may actually live in that contact box rather than in the password box, and so that may be just something to think about. One of the other things that browsers have a bunch of, and that locks me to the specific browser and sometimes the specific browser and the specific machine when I would like to have it in wget, is a whole bunch of OAuth tokens and other things like this that are supposed to be replacing passwords. So I don't have a good container to put them in that isn't a browser. I have a mail system, MH, that now has a mechanism that's very cool, and I know Thunderbird does the same thing, where you wind up with an OAuth token and you somehow store it somewhere, and I'm not actually sure it gets encrypted intelligently, and I certainly have no idea how to move it from one place to another. Okay, so those are not passwords exactly, but they are often bearer tokens, and I probably need to keep them secret, but I don't always know when I need to keep them secret because some of them are not bearer tokens. Sometimes there are other things attached to other things. So that may represent some box that is outside of this, and as we move to an API, based web with backends, there may be a space of non-user facing things that would like a way to do that kind of stuff. I just want to be able to share, my logins with my scripts that I do and not have passwords embedded in things. And I'm sure there are operational people that have, as I think Phil said, that have passwords embedded in shell scripts, and it's just disastrous, right, for that.
Yeah, to I think add another point, Michael, the discussion so far has focused, I think, way too much on web browsers, and I think it's been made clear that web browsers aren't interested in an interoperable protocol today to do synchronization of their particular pieces, but that doesn't invalidate. It sounds like there's other people that are interested in, is there a better problem space to do synchronization of cryptographic material of some kind? Somebody mentioned PGP. I would love to hear other ideas of, is there a better space? Because I think Phil's original idea may have some issues unless we find other users willing to, actually do an interoperable protocol around that area.
Chris Wood, Apple. Speaking as an operating system, we would not be interested in interoperable implementations of this sort of thing. Would not.
Would not. Of which sort of thing? Of passwords, you mean?
Of anything. I mean, we have iCloud Keychain, which does this sort of stuff, like Ecker was referring to earlier. So,
okay. Roman. So I guess the next steps would be where do we want to go from here, and what would the conclusions be? I think a safe conclusion is there's a fair amount of resistance from the password point of view. I did hear people's interest in some of the other technologies, especially DARE, as well as some interest in synchronization, although the problem space isn't well explored at the moment. Let's give it to him.
Yeah, and also there was couple people expressed interest in strengthening keys that are in TPMs and so on, IoT, or not trusting device embedded keys.
Right. To kind of pile onto that, the other thing I heard is we didn't dive into very specifically any of the blue boxes individually as well. I mean, we started very much kind of from the orange, which is how I opened the conversation. Which way are we driving it, top up or top down? But we heard feedback on one of the orange boxes.
Michael Richardson, and UDF provided a way to pass certificates by reference rather than value in constrained protocols. That was a requirement that I had. It fits upwards into the IoT box, but not so obviously. And I want to reiterate the IoT configuration backup and restore is, I think, a real problem out there. And I don't think that the other, quote, SDO market verticals, I don't think they're well positioned to come up with a solution that isn't going to suck. Okay, suck in a cryptographic way and probably in a product implementation way. And this is a place where the IETF, could be providing technologies rather than solutions.
This is Ben Kadek. So Michael, you're mentioning this sort of IoT configuration, synchronization, backup sort of stuff. Do you think we have people in the room or at the IETF who would be wanting to implement or to sell or to deploy that sort of thing?
The consortiums that I'm familiar with all have members from companies who have people in this room, but those people are not the same people always, but the companies are common. So that doesn't really answer your question, except to say that I think that with a little bit of, I'm going to say, marketing, that we may be able to pull those people into the right place, or at least those companies into the right places.
All right. So it's interesting. We're like right at the floating level of almost finding, a tractable problem, and definitely some that people aren't interested in, but people are interested in some of the blue and not entirely the red, and so it's challenging. And so I guess last comment, and then Roman, if you have any.
So yeah, Jonathan Hamill. There's been discussion about the blue boxes, and my question on technology, this meta cryptography, the key splitting combination, to me, I don't see an upgrade path to quantum resistant algorithms, because it's all based on Diffie-Hellman properties, which with current proposals for quantum resistant crypto, that the error is going to explode and you have to reparameterize and things like that. So my main concern is that by the time this is deployed, it's not going to be secure.
Interesting. Do you have a follow up on that, Phil, at all?
I've spent quite a bit of time looking at quantum cryptography. It's really difficult to know what the threat level is or what we can do about it, because it is really, trying to govern the unknown. What is clear to me as somebody who did experimental physics, you don't have computers today, you have physics experiments. They're not doing calculations, they're doing experiments in fundamental physics. The business about the number of qubits increasing, I don't think that the increase in it's not going to be like Moore's law. You're not going to see the number of qubits increasing incrementally. I think that it's going to be one day somebody will get the 50 qubit machine working, and the next they'll build the machine with 1 million. And so I think that a lot of so what I've thought about how to control that is, if I have connected together all of Alice's machines while we still have public key cryptography, and I can use that to authenticate, I can then use that to build in quantum resistant algorithms based on Kerberos and based on Lamport hash signatures. And right now, those are the only two things that I really feel comfortable with. So I do have a escape hole from all this, but it isn't based in,
All right, thanks. We won't go down that rat hole. So.
It's Richard Barnes from Cisco. So there was a question raised about IoT vendors. One of my roles at Cisco is to work on a few things that look like IoT, recognizing there's a spectrum of things and classes of things, but the problems my things have don't really map that well to this technology set. So I don't think this is the problems we're solving here in the technology suite we're talking about in this meeting is something that would really be useful to the stuff, at least in the space of IoT stuff I've been working on. I also like to second the concerns about post-quantum cryptography. I think we have, I think my concern is I'm not quite as blasé as Phil seems to be about the possibilities for quantum computation. I think it's worthwhile the effort the industry is investing in being prepared for that technology.
All right, I think with that, I don't know if the ADs in the room want to speak to anything or ask any more questions. I think we're out of our set of topics.
We just huddled together.
Okay.
Yeah, so Ben Kaduk here. I think you sort of summarized what we've been hearing correctly, that looking at the list of use case orange boxes up there, we're not getting anybody super excited who's in the room, but it sounds like we've got several people that are saying there's still potential to find somebody, and so we should be trying to find people who would have a use case and they'd be willing to adopt, deploy, implement this suite of technology for their purpose to solve a specific problem. But I think at the same time, or even before that, we can also revisit these sort of blue boxes at the bottom, the sort of foundational technologies. And so I would like to suggest that maybe we could do some of the standard BOF questions as hums for each of the 3 blue boxes. So like in particular, we could say, do people think they understand what UDF is trying to do? And then, if people do, then we could ask if people are interested in working on that and doing it in IETF.
All right, would you like us to do that, or did you want to do that?
Why don't you come up here? That way you can assess consensus and answer the questions. You got time.
Okay, so hi again. Oh, there's different spectrum on the monitors up here. Anyway, so I'm going to ask a bunch of questions for hums, and hopefully they will be in a pattern that will be similar, but Ecker wants to say something first.
Yeah, I mean, we really didn't have much discussion, unless I missed it, of the merits of these pieces of work, right?
Right.
So I think I'm like kind of like sad about having hums, and we haven't really had a discussion about like the merits of these pieces of work as standalone work items.
I mean, if the answer to the hum is people don't think they understand what it's supposed to do, then like your point stands. Yeah.
Okay.
So actually, before I do any hums, let me ask for show of hands. has anybody who's read the UDF document, the separate draft? It's what, like 10-ish, 15 maybe? And so for the DARE document, who has read the DARE document? Similar, slightly smaller set of hands, maybe 5 to 10. Same question for the key splitting combination stuff. Who's read the document for that? About the same, 5 to 10. Yeah.
Ben, may I ask a process question before we hum?
Yes.
So, and please correct me, David Skenazy, Google Chrome. Please correct me if I'm wrong, but in general, the BOF questions come like for a problem statement as a whole. And I'm very confused by the idea of splitting the blue boxes out into individual components, because I've heard a problem statement for the entire proposal of the mathematical mesh. I have not heard a problem statement for the blue box. So I would be very, or if someone were about to hum that they understand the problem statement for one of the blue boxes, could they please explain it to me? Because I didn't see that in any of the presentation today.
That's probably a fair point. So like, I will still ask the question, but you know, your point stands that we didn't really get a huge amount of presentation about the specific problems for the blue boxes. Michael?
We're allowed to have a second BOF in our normal process, and I suggest that maybe you're asking your questions prematurely then. Maybe you should ask, should we have another BOF? Should we proceed further with this rather than worrying about the technology?
I mean, I think that's a very valid thing to do if people feel like they need more time, more information, more discussion.
Or maybe what you should ask is, do you think we're done with this now? And if the answer is not a ubiquitous yes, then we should continue. If the group is hostile and opposed to all of this at this point, then that's enough information to stop at this point.
So can I reframe that as a more positive question, right?
If you like, yeah.
So let me rephrase it that Phil presented a number of technologies that might be useful in different areas. To me, what I would like to know is, do people believe that there are problem spaces that these technologies might be of interest to? And then so you can say no to that, and it still ends up becoming negative, right? But the initial question is there, did people see something in these presentations that made me want to work on it further, explore it further, even if we don't have all the information, you know, to date? Because there's a lot of technology in that, and it's hard to do in a 2-hour BOF.
So Wes, Martin Thompson here. One of the things that we do these BOFs for is to work out whether there's a constituency of people that are interested in working in the IETF on something concrete. They're going to build something that depends on having interoperability. And so that sounds very nice, and I'm sure that Phil would like to hear that, but I don't think that that has any bearing on a decision process for whether we have a BOF again or whether we drop this or anything like that. I think the questions that we need to be looking at here is there something that we can do concretely in the IETF? Is there a problem statement we can work on that requires interoperability between people who need that interoperability? And I'm phrasing the question that way may be information for folks who would be interested in pursuing this, but I don't think it has any direct bearing on the outcome of a session like this.
Right. And so the line of questioning that Ben has kind of started is, we heard in terms of how things were framed in orange, we didn't find a hit. What we're trying to ask now, if that's the top of the diagram, we're now trying to asking kind of bottom up. So given what you've heard about the blue, again, how much do you feel like you understand it? And should we talk more about blue because we still haven't hit the right thing with the orange as the correct use case? Is what we were circling
right.
to.
So I think if I could try to synthesize most of what I've heard, I would then propose to ask, is there any technology described in any of the boxes on the screen that you would like to learn more about, or think harder about, or think that the IETF should do work in potentially?
Yeah, Rich Saul's no hats, just to save time, not going to the mic. I think the idea of home networking password management is something that we could really address. We've done a lot of other home net kinds of working groups, and that does not overlap or get into conflict. Well, maybe Apple OS, but it doesn't get into conflict with the Chrome and the Firefox password management systems. But certainly IoT is coming, and being able to manage passwords in the home, and maybe it ends up being something you get in your ISP router. Who knows? But that is something that I would like to see move forward.
Okay, so let me try wording a question for Hum. So is there any technology listed on the screen or that was mentioned in person that you think the IETF should continue to discuss and potentially pursue? Can I get a hum if people think that they understand what that question means? And if you're confused by that question, please hum now. Okay, so that was not a very good question.
So trying to kind of restate it, given what you heard about the blue boxes, do you have something that would be equivalent to what you see in orange that could apply that blue technology? Hum yes if you think you understand that as a question. Hum no if you do not understand that. Melinda, you want to help us?
I don't know if this isn't going to help, but 10 people in the room, give or take, have read each of the documents, and we're being asked to evaluate whether or not the IETF should take on a substantial effort based on. Yep. So
We're being asked whether we want to keep talking.
Right.
Yeah, but it's still the case. 10 people have read it. I can see the value perhaps in another BOF, depending on what happens between now and March. But it does concern me that, we're talking about progressing stuff with people aren't interested enough to read the documents or don't have the time to, you know what I mean? There doesn't seem to have been so far much commitment from the folks in the room. And that's a concern. We don't work on stuff, as I said earlier, because it's interesting. We work on it because there's a constituency for it, that somebody plans to implement it, et cetera. So.
Yariark. So I think basically you're trying to ask these questions too early. Too small number of people read documents, and we understand too little of this. And then just too broad area for us to fully grasp exactly what things are interesting and what are not. I think this overall space is or continues to be very interesting. Obviously, there's going to be specific areas where there's existing solutions, for instance, or different trade-offs, and those guys are not going to be interested in applying anything new. But there's also many new things. IoT was mentioned here. And other things coming up in the future that might actually benefit from something like this. And I think the next step is not for us to ask too many questions, but for Phil and others to work on more specific applications of this, and figure out if there's interest in in the IoT community, for instance, or some of the other items here. And so that's I think it's more of a offline work than an IETF meeting thing. And then maybe they'll find something and come back next time and propose something more specific. I think that would be the way ahead.
Okay, we're out of time, so no more people at the mic, and please make it brief.
So actually, I'm sorry, Gadacker. I mean, we have kind of 2 minutes, so we want to pose a new question that was kind of suggested, which is, given the small number of folks that have read the document, let's tee up, based on what you have heard, would you be interested in finding out more and reading the documents? Could we get a hum on, do folks understand that question? Does anyone feel like that's a bad question, does not understand that question? Okay, so let's try that. Okay, so hum now if, based on what you have heard here today, you are motivated to read those documents and find out more.
And if you are not motivated, please hum now.
That's a good hum.
So kind of based on that result, we heard humming in the order that folks want to find out more and read more. We heard very little on the order that they're not interested in finding out more. And I think we're going to have to end it on that. So thanks so much.
All right. Thank you, everybody.
Enjoy your lunch. If you have the blue sheets, bring them up. If you haven't signed them, come up here. Yeah. Right. We are disinviting some people next time. That's all right. We're friends. Blue sheets, who's got them? Oh, great. Bring them up. And if you haven't signed them, come on up so you can sign them.